Hey, let's talk about batteries. Look, these are all the batteries that we got in currently. We got a huge truck of all kinds of different batteries. Basically all the scooter batteries and even some of these lithium iron phosphate batteries, right? So it's never been a better time to get into lithium batteries or build projects with lithium batteries because there are abundant. There's every day there are more and more kinds coming to us in better and better shapes. A lot of these are brand new, unused. For some reason, they didn't make it to their destination. They didn't make it to the end product, right? Or their application. And so they end up in our hands. And then what I'm doing is finding ways to use them. But here's the thing. I'm not the only one that's doing this, that is selling batteries, right, on the internet. But most people, what they do is they'll sell you the batteries so that you can harvest them. You know, they'll sell you a battery sort of like this, that it's like dead. You don't know how to use it. It's up to you to figure everything out. And most of the times what ends up happening is that a lot of you guys have to take them apart, right? Sort of like this one. You take it all apart, you rip out all the, all this stuff so you can get to the individual cells. And that's great. It's been great for a long time. There's a way to get really affordable cells, right? But in my opinion, that is not the best way to use these batteries because you're undoing a lot of this work. These are already packs that are put together and you're gonna take them apart and then you're just gonna, put them right back together into another pack, right? You're just undoing work that you're about to just redo. And so a better way to use these is to find an application where you already just use them, right? And so some of these are ready to use as is. You don't need to do much other than just charge them. Some of them require you to maybe like change a connector because for different reasons, because we can't find it. So like this connector right here is very rare. So it takes a long time to get it from China. We're currently waiting for a bunch of those connectors. Some of these require an extra piece of hardware to be able to activate them so you can use them, sort of like these ones right here and maybe these ones. I still haven't figured those completely out. But some of these are kind of ready to go. All you have to do is just change like a connector or something. This is the battery pack that I want to talk to you about today. A lot of you guys for a long time have been asking us for 12-volt batteries. And for the longest time, we haven't been able to give you anything. The lithium batteries usually don't make a good 12 volts, right? Automotive 12 volts. And a lot of you guys that are into RVing or for some reason want a 12 volt because the 12 volt the equipment it's much cheaper because it's way more abundant in the marketplace, then you guys haven't been able to use the readily available and affordable cells that we have been using at 24, 36 and 48 volt levels, right? But here, for the first time now, we have a pack that is perfect. This is a 4S lithium iron phosphate, right? So lithium iron phosphate, there's a lot of advantages to that because it's safer, right? So this is not as reactive. This will not catch fire as easily as the lithium cobalt oxide versions of cells, right? And the other thing is that these are long lasting. Usually lithium iron phosphate will last typically between 4,000 and 6,000 cycles, where the other ones are somewhere around 500 to 1,000, right? So these have 3 to 4 longer cycle life than the other chemistries. So these are really cool. So this is what they look like, right? They come with this little wimpy connector, which is not ideal, but they work. All you have to do is charge it and then these work, right? For some reason, they all have this cut. So there's this shrink wrapping is cut like that, but you could rewrap it. You could put a piece of tape. That's an easy fix. I took one apart to see what is inside. And what turns out to be that it's a pack that is made out of 5 smaller packs that are individually wrapped, sort of like this, right? Here we go. And they have 3 BMSs per pack. So 4 cells in series, and then 3 of these it goes into a BMS, and then there's 3 of these into each one of these little bundles, right? And then there are 5 of these that make up that. All that exits via these tiny little wires. That's the only thing here that is not ideal, because that means that these little wires, well, they are skinny, and so that means that the power output is not going to be very high. And at lower voltages, sort of like 12 volts, you want the power outputs to be higher, right? So here's the connector, the original connector, right? So this connector's, this connector is rated at 20 amps, but you're really pushing it at 20 amps. Those little pins will get hot and stuff. And definitely these little cables here will not do 20 amps. And so we'll have to change that. And so that's what I've done onto these ones here, just to see how far we can push it, right? This is the limiting factor. Here's the connector. Then the next limiting factor is going to be these cables, right? They seem skinny, but there's 5 of them. So we'll see. Maybe I'm estimating that they will be able to do about 30 amp continuous, right? So of course that is if the BMSs are capable of putting out 30 amps all combined, right? I don't know. The MOSFETs on the BMSs say they're good for 8 amps. I think I read somewhere online. But I think because due to the cables, maybe we're thinking that it's going to be lower. So anyways, we have to do a test and see the power output. Another one thing before we do that is that you can see that there are data cables. These are 2 little cables that are in here. And so taking it apart, I'll show you what's in there. Okay, so once I took apart this pack right here, one of them had this extra PCB on it, just on the side here with a piece of tape. And that's what these other 4 cables go into the connector. Once you start looking into that IC, that chip right there, it says it's an EEPROM chip, which as far as I understand, EEPROM is, well, that's just data storage, right? So I think what this is, first I thought it was maybe a temperature sensor, but I don't think that's what it is. I think this is a way for whatever this device that this battery was designed for would store data about the battery, probably cycle life, probably calendar life. Maybe there's a temperature sensor and they would keep that in there. I think that's what this chip is. It's probably just like an ID chip that will keep track of the life of this battery, right? And so the only weird thing is that it's not really connected to the battery. It's only connected to the battery via the device that this was designed to power. And which, by the way, we don't know. I don't know what this was designed to power. Something low power, obviously, right? Because of the tiny little connectors. And there are several of these batteries. They're in similar configuration, this sort of cylindrical, shape, about this size, lithium iron phosphate, most of them, and there's several like voltages. These are the 12 volt 4S, but there's also a 5S, which is 16 volts nominal, which is kind of a weird thing, but we will find a use. I will try to find an application for those. So now let's load test this pack right here. I'm choosing this one that I've taken apart so that we can have a view of all the cables, a lot of the BMS boards, all the stuff. If it starts getting too hot before they shut down, then we'll be able to see that through the thermal camera and be able to touch it and have a good way to notice that, right? So I also have a clamp right here, and that's what's going to keep track of the amperage. Let's run the test. Here we go. So let's increase. Oh, what? All right, I accidentally triggered the BMSs off because the inrush was too much, right? I couldn't control it as finely as I need to. So what I'm doing here is I added a second pack, and that way they'll be able to handle more of the inrush. But we'll still be able to document, right, and monitor what this single pack right here is going to be doing. And so let's start it now. So there we go. 10 amps. $15 amps. $20 amps. Let's leave it there for a tiny bit, and then we'll check it with the thermal camera. All right, it's been a few minutes. We're running at around 20 amps per pack. This one right here, which is the closest one to the exit, is seeing about 1 amp more than this one over here, right? So let's look at the cables here. This is at 20 amps each. So 30C, that's room temperature. They're warm. They're starting to get warm, but like there's nothing. I mean, not really, not much, right? What's my hand? Yeah, my hand's at 30C, right? So it's room temperature. These are 32, so maybe 1-2 degrees above ambient. Maybe this big cable right there, that's seeing 40 amps or 42 amps, something like that. Okay. This is all safe. Let's see how much further we can push these batteries. All right, now we're gonna increase the power until these completely shut off. We're gonna do this quick so that the cables don't have time to heat up and melt and stuff. But if everything, this is a well-designed pack, then the BMS is gonna give out before the levels get high enough or to start melting the cables, right? That's what you would want to do when you're designing and building a pack sort like this. You want the safety measures so that your battery cannot melt itself off, right? So let's see if they did a good job. And start pushing this. 23, oh, that's it. So basically around 23 amps. What? We were right there. So after 23 amps, this gives up. The BMS is basically shut off. 23 amps is not gonna melt these cables. So yeah, these are well-designed packs. That means that you can get a maximum of 20 amps per one of these packs. That's actually very good news. All right, so now this setup here, I have 4 of these batteries, and at 20 amps times 12 volts, right? That's about 250 watts or something like that. And these are 288 watt hours. So these are essentially 1C, where they are BMS'd, right, at 1C capable. So that means that this right here setup could do about 80 amps or just nearing about 1 kilowatt. We're gonna push this setup again, and just to show you that the cool thing about having individually BMS packs like this is that you can grow your system, right, by just adding more. But if you go over that, if you make a mistake and all of a sudden you're asking too much of your batteries, then you don't have to worry about it too much, because then the BMS is going to save you. It's just gonna shut off and protect your batteries and your cabling and all your equipment, right? So here we go. We're gonna add, there we go, 10. So there we go. There's about 21 on that one. Let's see if this is well distributed. It's not. See, this is 19. This is 20. 19. Okay, so 2 of these packs are pushing about 1 amp more because of where the power is being taken off of this power strip, right? So the overall into the inverter is 80. So we're exactly around 80. This is the max that these will do, right? So that means that we'll be able to push it just a tiny bit more, and then these batteries should turn off safely. So here we go. We're gonna do it. Ooh, it went all the way to 90. Look at that. How did it get to 90? Let's look at the individual packs. Ooh, look at that. This one is doing 24. Well, that is different than the last time. This one's 21. Is this one 24? 23. 21. Oh, that is weird. Why aren't these shutting down? Well, this is a good test. Yeah, these wires are just starting to warm up a tiny bit. Well, let's push it. Let's see how far we can push it before it shuts down. We're at 90. Oh, that's the max that this system will do. I'm all the way up with this heater. Okay, let's leave it there for a little while and then check the temperatures, because now this is higher than we had tested before. Okay, so it only lasted a few minutes, probably like maybe a minute and a half, and then after that it shut itself off. So again, these didn't get as warm as these ones, because these were seeing 92. So if you do the math, 12 times 92, that's 1.1, which is exactly what this is, 1.1 kilowatt hours, right, at 1100 watts that you could put up. So that's exactly 1C. So I guess maybe these are capable of just a bit under 1C on a continuous, right? I bet you these will do 20 amps for long time. Like I've tested like 20 minutes like I tested before, but at 23, these will only be good for a few minutes. So there you go. The results are in, unmodified, just the way they are with this little connector. This is a good 10 amp continuous output battery, right? All you'd have to do is just build something like this that have these little connectors, and then connect a bunch of these, and then you could build a big battery system, right? That is 12 volts, and each one designed to only give about 10 amps each, right? Of course, you can better that by just changing the connector, sort of like what we did here, and that our testing resulted in 20 amp continuous and burst of like 24 amps for a few minutes before the BMS will shut off. But either way, you can use these. These are safe because the BMS will shut off before these little wires start melting. These cables start getting warm around 20 amps, and they start getting hot somewhere around 30 amps, right? But of course, the BMS will shut off before that, so you don't have to worry about wiring these wrong and then have these, melt and stuff and burn anything, right? So with the use of a little DC power strip like the ones that we sell at Jack 35 like this, then you could make large battery systems using these. You could also put them in series if you wanted to do more than 12 volts, right? But obviously there are other batteries that we have here that you will be able to do that. We have our 10S scooter battery packs that will do up to 25 amps, and those are already at 36 volts, right? 42 fully charged, 36 nominal voltage. So maybe those will be better for your application, but you definitely could, wire these in series so you can higher the voltage to up to 24, 36, or 48. But obviously these are ideal for running a 24 or a 12 volt system, right? These are 1C, so these are 288 watt hours, right? Here we go, 288 watt hours, and you can get about 250 watts continuous. So this would be a 1C rated pack, all right, with internal BMS. So keep in mind when you're designing your system that way, right? If you wanted to build, let's say, a 10 kilowatt hour Powerwall or battery system, well, you just divide 10,000 by 288, and that gives you somewhere around 35 of these modules. And so you'll be able to do that, and you could get up to 10 kilowatts for your 10 kilowatt hour battery pack, right? As long as you do this and change the cable, right? The connector. If you leave the original connector, well, you can get probably half of that, like 5 kilowatts for every, so about half you know, half a C output and stuff. So just keep that in mind. These are available at Jag 35. I will be making a build, right? A very detailed build where I show you how to build like a thing, like a portable power source that you can use maybe as backup or something. I don't know exactly what I'm going to build, but hopefully I can get to that quick. I already ordered some PCB boards because I'm thinking of some designs. And so stay tuned for that. There's also, I'm going to be talking about the other types of batteries as I find the applications for those, right? So thank you for watching this video. See you guys on the next one. Bye.